Hey everyone, in this second in a series on verifying trig identities, I'll show you how to verify an identity using a Pythagorean identity. And remember, these are all based on this equation, sine squared theta plus cosine squared theta equals 1. It's also helpful to remember you've got the reciprocal identities you can work with. So let's take a look at this problem. We're asked to verify this identity, 1 minus the sine of x over cosine of x equals cosine of x over 1 plus the sine of x. So looking at this 1 plus sine of x, I start thinking about this expression right here, that 1 minus sine squared of theta equals the cosine squared of theta. So I'm going to just work on this one side of the problem. Now in this case, it didn't matter which side I chose because they're both of equal complexity. If one was more complex than the other, I would always choose to work on the more complex one. And remember, always just work on one side of the problem all the way through. Don't work both sides of the equation, just work one. So to get a 1 minus sine squared somewhere in here, I'll multiply by 1 minus the sine of x over itself, 1 minus sine of x. So that gives me cosine x times 1 minus sine of x over 1 minus sine squared of x. Now I also know that I can rewrite that as, okay, the numerator is staying the same, but 1 minus sine squared is cosine squared. So 1 minus sine squared x equals cosine squared x. That's straight from a Pythagorean identity. Now, in this step, I'm just going to write these clearly as factors. You don't really need to do this, but just to make sure I clarify what I'm doing here, I've just rewritten the problem so that cosine squared of x is expressed as cosine of x times cosine of x, because I want to cancel out common factors. And that leaves me with 1 minus the sine of x over the cosine of x, which is what we set out to prove. So we are finished with that identity.